Question number 4 says evaluate integral 1 to 4 x square minus x dx. Now how will we do that? Once again, the process is simple. We have seen this process, and let's observe that process again. The conversion of integral to definite to limit as a sum will be the steps follows. Integral a to b fx dx can be written as, this expression can be written as limit n tends to infinity b minus a upon n. In the bracket you will have f of a plus f of a plus h plus da 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 f of a plus n minus 1h. This is what you'll have, right or not? Yes, this is what you'll have. This is a complete bracket. Okay, now once we have seen this, in this function can you identify, in this given integral, can you identify a? The value of a can be identified easily as 1, the value of b is 4, fx is x square minus x, and h, the value of h is b minus a upon n, b minus a upon n, which is 4 minus 1, 3 upon n, which tells me h is equal to 3 upon n. This is the value of h. Okay, now once you are aware of this much, therefore this I, this integral I, which is integral from 1 to 4 x square minus x dx, can be written as limit n tends to infinity, using this limit n tends to infinity b minus a upon n, which is 3 by n. In the square bracket I have f of a, which is f of 1 plus f of a plus h plus f of, at the end, f of a plus n minus 1h, which is 1 plus n minus 1h. This is what you have. Is that okay? Yes. Once you are clear with this, this will simplify to what? Limit n tends to infinity is okay, 3 by n, and what is this? F of 1. So f of x is x square minus x. So f of 1, let me write f of 1. This will be 1 square minus 1, right? Plus, what do we have? 1 plus h. F of 1 plus h will be 1 plus h square minus 1 plus h over here. Yes, this is the next term. Plus dot dot dot. And what else? The last bracket will be this square minus this term, right? X square minus this. So 1 plus n minus 1h, it's square, x square minus 1 plus n minus 1 into h. This is what you'll have. And yes, that's a complete expression over here. That's a complete expression. If you take a look at this, this is the last term over here. Okay. Now identify, take a look at these terms, and the next step will be very, very important, very, very crucial for analyzing this whole question. Because if you observe each and every term, this term does not have any h. All of these terms have h. So total there are n terms, and terms having h will be total n minus 1 terms, right? Okay. If you identify, observe the square terms carefully. So 1 square, 1 plus h square, 1 plus n minus 1 h, n minus 1 times h square is what I have, and I'll simplify that first. This is equal to limit n tends to infinity 3 upon n in the bracket. Let me club together the terms having square. So this is 1 square plus, what is this term? 1 plus h square plus the next term will be 1 plus 2h square plus similarly this term will be 1 plus n minus 1 h and its square. Curly brackets closed, right? I have clubbed together the terms having square. Then after this curly bracket, I'll open another curly bracket. There will be a minus 1, minus of 1 plus h, and similarly minus of this. So minus has been taken out common. You'll have 1 plus, you'll have 1 plus h plus, from the next term you'll have 1 plus 2h plus similarly from this term you'll have 1 plus n minus 1 h. This is what you have, and yes, curly brackets closed, and then the square brackets closed. So this is one part, this is the other part, obtained from x square and x respectively. 3 by n is there outside, right? Observe this last step carefully, and then we'll continue further over here. So let's continue further with this term over here, and what does that give me? Limit n tends to infinity. Therefore, I will be equal to limit n tends to infinity 3 by n bracket, square bracket actually, and what does that give me? Curly brackets, 1 square plus this 1 square, this 1 square, and this 1 square. So there will be 1 square how many times? 0, 1, 2, 3. This is n minus 1h, n minus 2h, and similarly there are basically n terms and all. So 1 square will be added how many times? N times. That's the first thing that you observe. Then you'll have 1 square h square, 2 square h square, 3 square h square, and similarly n minus 1 square h square. So let me take out h square common, and I'll have 1 square plus 2 square plus dot 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 n minus 1 square. This is what you have. Is that okay? Yes? Okay, this is n minus 1 square. Next, let me take a look at the third term, which is obtained from here. 2 into 1 into h, 2 into 1 into 2h. Okay. 2 into 1 into 3h, 2 into 1 into n minus 1h. So if you observe, I can take out 2 into h, 2 into 2 into h, and 2h common basically. I can take out a 2h common, and what will remain is 1 plus 2h common times this 2 plus 3 plus dot 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 plus n minus 1. Similarly this is what you'll have, right? And that's the first curly bracket has been simplified up till now. There's simplification of just the first curly bracket minus the second curly bracket begins now. You'll have 1, 1, 1, how many times? 1 comes n times, plus this h times 1, h times 2, h times n minus 1, h comes how many times? 1 plus 2 plus dot 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 n minus 1 times. And then you end this square bracket. That's the simplification of this. Okay, now the next step. Let us use a different color. This becomes limit n tends to infinity. 3 by n remains outside in the square brackets. What do I have? I have n, then I have this expression in the curly brackets. Okay, n plus this is h square. Watch it. What is h square? H is 3 by n actually. We'll replace that later. But h square times this whole expression, sum of squares up till n minus 1. So that will be sum of squares up till n is actually equal to n times n plus 1 to n plus 1 upon 6. This will be up till n minus 1, that will be n minus 1, n minus 1 plus 1, 2n minus 2 plus 1, which is 2n minus 1 over 6. Then you have 2h times this whole expression plus 2h times you have sum of squares up till n minus 1 terms, which is n minus 1 times n. n minus 1 times n, let me write the n upon 2 over here, and this is this particular term simplified. There's a minus after that, so minus n is what I'll get, and this minus will go over here, minus h times this whole expression, which is n times n minus 1 upon 2 is what I'll get. Is that okay? Yes. Then close the square bracket, and now let us cancel some terms. I see some terms getting cancelled. N goes with n. Okay, 2 times hn n minus 1, hn n minus 1 upon 2, hn n minus 1 upon 2, 2 minus 1 is what I'll get, 1 times that whole expression. So this will convert to limit n tends to infinity, 3 by n goes inside, 3 by n into this h square is 3 by n again, 3 by n square, this is 9327 upon n power 3 times this whole expression n minus 1 2n minus 1 upon 6. This is what I'll be getting, right? What else? This term minus this term will be single term over here, and 3 by n gets multiplied with this h. 3 by n into 3 by n will be 9 by n square, and there will be n minus 1 upon 2. This is what you'll get over here in the square brackets. Now if you take a look at this whole expression carefully, what you'll see is this is this is giving me a term of n cube. There's n cube over here. Limit n tends to infinity. 27 upon 6 will remain as it is. And this 2n cube upon n cube will be converted to 2. Rest all terms will become 0. Plus this 9 by 2 remains as it is. N square upon n square will be 1. Okay, that was limit n tends to infinity will give me this. And from here now I can observe, okay, 6 times this is 2 and this is 3. 3 times this is 9. 9 plus 9 by 2 is what I get. Okay, 9 plus 9 by 2. This is 18. 27 by 2 is what I see over here. That's the required answer for this particular question. That integral using the idea of definite integral limit as a sum is equal to 27 by 2. That's the final solution and the complete answer for this question. Let me get a side so that you can take a look at this complete solution over here. This is the fourth question for us.